Welcome back to OK Calculus. Last time I talked about particle motion. This time I'm going to explain how to find tangent and normal lines. It's true, we have found the slopes of tangent lines before using derivatives, but this time we're going to find the slope and the coordinates of the point of intersection. So we're going to be finding the equation of the tangent lines as well as normal lines, which I'll explain what those are. So a tangent line, so you got the curve here. So that's the curve. A tangent line would be, the line that's tangent right there. We're going to be finding the equation of that line. And a normal line is actually the line that's perpendicular to the tangent line. So it would go like that. Perpendicular. Alright, so the first equation is f of x equals x cubed minus 3x, and it asks us to find the line tangent at x equals 2. So we're finding the equation, of the line that's tangent. So first we got to find the slope, and that's pretty easy to do. You're taking the derivative, which we have done before, using the power rule, bringing the 3 out front and dropping it by 1. Get 3x squared minus 3, and then just plug in the 2. So that equals 12 minus 3, which is 9. That is the slope. That's not the answer, but that is the slope, so that's part of the answer. So now what we got to do is we got to plug the 2 back into the original equation, which equals 2 cubed is 8. 8 minus 6 is 2. So at the point 2, the slope is 9. So you gotta write that in the equation now. So if you use traditional equation methods, so you got y minus 2 equals, and you put the slope there, 9, x minus the x. And that would be your equation. Right there. And now the next part asks us to find where the tangent line is horizontal. Now when a tangent line is horizontal, that means the slope is 0. So you're basically just taking the slope and making it 0. And so that would be the derivative. So 3x squared minus 3, that's the derivative function, but you got to make that 0. You got to find out where that's 0. And if you just use traditional factoring methods, you go 0 equals 3, factor out the 3, x squared minus 1, and then you can factor that again. 0 equals 3 times quantity x plus 1, x minus 1, and then from there you can deduce that x equals 1 and negative 1. Those are the two x values where the tangent line is horizontal. Now if you want the y values, you simply plug these two back into the original equation. Not this one. This is the derivative. You got to plug it back into the original equation. So you'd plug that back into f of x. So f of 1 equals, well, it's 1 minus 3, so negative 2. And then f of negative 1 is 2. So you'd say at 1, negative 2, and negative 1, 2. Those are the 2 points where the line tangent is horizontal. Alright, and then the last part asks to find the equation to the line that's parallel to this equation. X minus, or 6x minus y equals 5. It's asking us to find out where when it's parallel. So first I gotta find where the slope is. So you gotta solve for y. So subtract the 6 over, and then divide by negative 1. You get y equals negative 5 plus 6x. And as you can see, this is the slope right here. So you gotta find out where it's parallel. And parallel would mean the same exact slope. So you gotta match that slope. So you put 6 equals the derivative. So 3x squared minus 3. And then you solve for x, so you get 9 equals 3 x squared. 3 equals x squared. And then what you want to do is you want to take a square root of that, a square root of 3, and actually plus or minus because you're taking square root, so it could be either equals x, and then those would be the two x values, plus or minus root 3, and if you wanted to find the y value, you just plug it back into the original equation, and I'm not gonna sit there and do that, so I'm just gonna tell you what I got. So I got, if you plugged in a positive root 3, you end up getting 0, and then if you plugged in the negative root 3, you end up getting like negative 10.392. Those are the two answers. Those are the two spots where it has that slope, or is parallel to that slope. Alright, thanks for watching. That was just an overview of how to find the slope of tangent lines and normal lines, and just kind of some complicated problems that they might ask you. And thanks for watching.